We are going to take a look at applying transformations to parabolas and determining the maximum or minimum. Now, a transformation is a change in the location of or shape of the graph. One of them is a shift, a slide. It just moves someplace else. That's all it does. Okay? I mean, if you want, you almost got to think about this as sighting in a rifle. You put it on paper, you see where it's at, you keep moving, bringing it down, bringing it up, left or right, depending upon how it goes. And each click that's on the scope can be identified for how far you move it. Okay? So if one click is a 1/4 inch, then you know what it is that you want to bring it over. 2 inches, you got how many clicks you got to bring it over. Same kind of an idea here is we want to be able to figure out how this changes. So what we're going to do is we're going to graph these two equations. So you're on the graphing calculator. Make sure you reset it. Okay. So now the first one that we've got here is in parentheses, and make sure you type it in exactly as you see it. Parentheses, x minus 3, close it, squared. The other one is x squared plus 4. And now the last one that we're going to put in here is the parent function. The parent function is the base function for all of these. It's the parent function. Everything else gets moved off of that, which is just plain old x squared. So let's watch how these graph out. So we got one over there, that one's there, and we have the original. So the first one got moved to the left, right? Or right? Left? Which way to go? When we graphed out the first one, which way did it go? Left, right, up, down? Move to the right. The next one moved up. So we can go and figure out how these were moved. For the first equation that came over here, you'll notice it has x minus 3. So that means it was 3 units moved over. 1, 2, and 3. Now, I need to determine the vertex. If I take a look at the first equation that we had here, y is equal to x minus 3 squared. The vertex is sitting down here. So its vertex is at 3, 0. How do I know that? Because it got shifted 3 units to the right. If I were to go and put the trace on this, and see, I want to go on to my first equation, I put 3 in here, I end up with 3 and 0, and it is down here at the bottom. So I've got it sitting down here. The next one we had done was y is equal to x squared plus 4. Where did it go? For those of you paying attention, following along, and pretending you're interested. It moved up, correct? So if I go and set this so that I have this equation listed in there now, y2, and I put in 0, I see that it's flashing at the bottom down here. That's its vertex. And its vertex is going to be 0, 4. Now the original equation, y is equal to x squared, being the parent function, we know that it is at 0, 0. So when we look at these equations, we can tell how things are going to move, which way they're going to move, just by looking at the equations. So one of the things that you need to make sure that you have written down is this idea, vertex form of an equation. And that H and K represent the vertex. So I'm going to give you a few moments here. Make sure that you have that written down in your little ones. Now, when I take a look at the equations that they had given us, if I fill in all the missing pieces, now mind you, they gave it to us as y is equal to x minus 3 squared. If I fill it in to make it look like this, my a would have to be 1, because that's what we put out in front if we want to multiply by something that doesn't change. Here I need to add something. Well, I'm going to add 0, so it doesn't change. So if this would be the 1, this would be plus the 0. When I look at this, it says y is going to be equal to a parentheses x minus h squared plus k. All I have to do is take the information right out of there, and I've got my vertex. So my vertex here would be 3, comma, 0. And isn't that what we figured it out to be? 3, comma, 0. The next equation that we had, if we put it in there in that form, would have been y is equal to 1 parenthesis x minus 0 squared plus 4. Because that one just started off as good old y is equal to x squared plus 4. That's what we had to begin with. So if I fill it out so that I know where my x, y, and my h, and my k, and my a are, this one I pull it out and it comes out to be 0 and a 4. Exactly what we had to begin with. So being able to write the equation in this form is extremely helpful for us. We can always use this to go and identify where the vertex of the parabola is. Now we have also seen earlier in the year where we had the vertex of the parabola also identified where the line of symmetry was, right? So, let's try this. Using the vertex form of symmetry to graph a quadratic equation. Now, grab a graph here. Okay. I want to graph this out. So, where is the vertex on this thing? Well, if this is my h and this is my k, first offhand, is it in the proper form? Where we have y is equal to a times x minus h squared plus k. Is it in the proper form? And when I mean proper form, I want you to take a look at the signs here. Are these correct? Okay. Do I know what a is? Well, I don't have one, but what could a be then? Wouldn't that just simply be a 1? So now, do I know what h and k is? And the answer is yes. I know that h is going to be 3, k is going to be 1, so I know that this vertex is going to be at 3, comma 1. So over 3, 1, 2, 3, up 1. Now, I want to know what this thing is going to do. Is it going to open up or is it going to open down? From what we have done before, we should know that 1 here is what? Is 1 going to help us out with anything? Hoping you're saying no, because it doesn't help us out with anything. I don't want you to go and say that, oh, that's the y-intercept because of x is 0, because we got this going on in here, so we need to be careful about that. So if I wanted to identify what this is, what happens if I did this? I just simply put in, I want to say that x and y, so we got these again. If x is 0, what do I get? put x in. X minus 3 is negative 3. What's negative 3 squared? Negative 3 squared? Isn't it just 9? 9, and then I add 1, I get 10, right? So that means that 1 over here at 0, I got 10. I've got a point here. Now, because I have got symmetry going on with this, remember, David, you got to put the parentheses around negative, holding it to the 3, and then square. Then it'll work. So, yes, sir. Which one is negative 3 squared, the first one or the second one? The second one, because it's negative 3 being squared. Gotta remember that, so always catch on that calculator. So, I have got this idea of a parabola that it's symmetric. One side is the same as the other, correct? So, if I know that I've got this as 10, that's 1, 2, 3 places over, would I have another one 1, 2, 3 places over here? Should that be correct? Because if we've got our zero, our vertex down here, it should be coming up. What happens if I put in, say, let's put 1 in? What's 1 minus 3? What's negative 2 squared? 4 plus 1 is 5. 1, 2, 3, 4, 5. So it should have a point here. And likewise, there should be a point over here. So if that is 5, because of symmetry. What about if I put in 2? If I put 2 in, what's 2 minus 3? Negative 1. What's negative 1 squared? 1. What's 1 plus 1? 2. So I know that it's going to be right here, and there's going to be 1 right there. So if I put 2 in, I get 2 out. And since the vertex was at 3, 1, I have enough information here to come up with my parabola.
Basketball players are not Jews.
Okay? So I've got my parabola. That's it. So, one of the things that we need to pay attention to here is the sign of what is going on. How do I know if it opens up? How do I know if it opens down? If I look at this and I have a negative, so if I'm looking at this one over here, this one here going up could be y is equal to x squared. The one that's down here is going down would be y is equal to negative x squared. Now, we just got done talking about this idea of having parentheses on there, and if it's being negative squared, okay? Remember me telling you, whenever you replace a variable with its value, always put parentheses around it, correct? What happens if I do this and I want x and I want y, I put into the blue one, I want it to be 1. What do I get out of it? I get 1, correct? What happens if I put negative 1 into it? What do I get? 1, correct? What happens if I put that into the purple one now? I put 1 into here, what do I get out of it? Well, if x squared when I put in there 1 was just 1, this is going to be 1. There's this negative out in front of it, so now I get negative 1. If I put negative 1 in here, negative 1 squared is 1, but there's a negative out in front of it, so it's negative 1. So you have to be very careful about what it is. are asked for them that you can find them. So, another thing that we've got here, it says a absolute value of A, vertically compressed or stretched. Now, this can be a little bit deceiving. If A is between 0 and 1, if you multiply something by a fraction, what does it get? If I multiply something by a fraction, it gets what? Bigger or smaller? Smaller. If I multiply by a number that's larger than 1, it gets what? Larger. I mean, this kind of makes sense about it. However, here's where it kind of gets a little on the strange side. If I look at this one right here, y is equal to x squared. You've got the regular old parabola here. But if I take 1/10, it comes down here. Does that make sense to you? Think about this for a second. If I am using y is equal to x squared, and I put 1 in, I get out 1, right? If I put 2 in, I get out 4. If I put 3 in, I get out 9, right? Now, what happens if I have to go and take y is equal to 1/10 x squared? What happens then if I put in x and a y? If I put in 1, what is 1 squared? 1. But that means it's 1/10. Is it going up as fast? This went up by 1 unit. This only went up by 1/10 of a unit. If I put in the 2, it doesn't go up to 4. It goes to 4 over 10, which would be 2/5. It's going up at a slower rate. So what happens here is when you have a value that is between 0 and 1 for A, that's out in front, it squishes it down. It makes it stretch out. Okay? It's vertically compressed, horizontally stretched. I mean, if you think about it, you get those balls that you guys use for, I can't even think about it, for a dodgeball. If you take the ball and you squish it together, you can compress it down vertically, but what happens to the ball itself? It spreads out. Okay? Same thing, you even had a marshmallow on there. You squish a marshmallow, it gets fatter. Now, what happens if you run this idea of it, y is equal to 10x squared? Okay, take a look at this again. X and y, I put in 1, I put in 2. Okay, if I put in 1, well, 1 squared is 1, but I have to multiply it by what? 10. So that ends up being 10 over here. So instead of it just going up to 1, it's got to go all the way up to 10. So by putting a larger value in here, it grows faster. If I put in 2, 2 squared goes to 4, but 4 times 10 is 40. So instead of coming over here to 2 and going up to 4, it's got to go all the way off the graph up to 40 before it gets to the next point. So a larger number makes it go up faster, vertically stretched, but it gets narrower. So you think about that poor old marshmallow again. Grab that marshmallow and you start pulling it up, what happens to it starts getting thinner in the center. Oh yeah, it does that too. So you got to have an idea of what it's supposed to look like. So I've got these 4 graphs here and I got these 4 equations. What goes with what? Which one goes with which one? Why? Just looks like it's right. Well, and that's fine. When you take a look at it, you see that it's got a 3 out in front of it. That's make it going to go faster, right? So that's going to stretch it up. So you are absolutely correct in that this one is B. Yeah. Okay. Is he correct? Yes. The negative goes out in front of it, it flips it down. D. Okay. Absolutely correct. So, let's take a look at this one. Now I need to find the equation of a parabola. So I got to take all the stuff that I've done so far and put it together. Now remember, our equation is y is equal to a times x minus h squared plus k. First thing I want to find here is h comma k. Where is the vertex going to be? Well, vertex is going to be right there, so that's going to be 2 comma 3. So I already know what those values are going to be. Now, on the A, is it going to be positive or negative? It's going to be negative because it's opening down. So I know that here, A has to be negative. Now, the next question. This is where it gets a wee bit on the tricky side. Okay? I am right here at 2 comma 3. I move over here, and I am looking at negative 5. So what I would like to know is how much is that being changed by? Okay. So you said that it was going to be, oops, so if I'm looking at this, this went down, you said 8. 1, 2, 3, 4, 5, 6, 7, 8. So that went down 8. Okay. How far over did it go? 1, 2, 2. So I need to know this because if I put in a value, I need to know what it's going to come out by. So now if I look at another point on here, I see that I have another point that's over here. Okay? How far did it get moved over? 1. And how far down was it? 2. Okay. Now, how can I deal with putting in a point that's going to do that? Okay? How do I get it to move from 1 and down over 2? Move over 2. Okay? So, here we go. We know that this thing, I realize that you didn't. So y is equal to, because we're working on the a bit, right? We know that it's going to be negative. We know that it's going to be x minus 2 squared plus 3. So now, x, y. Let's put in the number 3. Okay? I'm going to put 3 in here. Now, if I put 3 in here, what is 3 minus 2? 1. Okay? What's 1 squared? Okay? Plus 3. 4. So I ended up with a 4. But what is the value that it should have ended up with? 2. So what would I have to multiply 4 by to get to 2? 0.5 or half. So it looks like if I had a half here, that would be okay, right? But it's got to be what kind of 2? Positive 2. Well, let's see if this works. If I go and multiply this by a negative, if I take 4 times negative half, do I get a positive 2? Do I? No, I don't. Okay. That's kind of disheartening, isn't it? So, let's try a different thought. What would it have to be in order for that to happen? What if you want negative half out here, and I do all this other stuff, what am I going to end up with? That's the question. So do you got another thought about how I can deal with it? Yes, I know it's done. Okay. So, what can it be? What do I got to do? Now, my question is, you said you wanted it to be a half. Is this thing squished or stretched? Going up and down? Stretched. So could it be less than what it's supposed to be? Is that possible? No, that's not going to work for us. Okay. So we can't have it because if that's half, that means it would be fatter. So we got to think of something different for it to get there. Now, sometimes having that negative in there really causes an issue. Let's think about it without the negative. If this was supposed to be at, this here is at 4, right? Or 3, and it went down 2. If I reflected it up and I didn't have the negative on there, it would be at what? Is this an ugly way of doing it? See, this is what happens when you want to use guess and check. And I like going through it like this and kind of beating your head up against the wall with it for a few minutes so that you understand that guess and check doesn't always work. I mean, yeah, we could flip it on over here and think of something different. Now, what I am going to show you is how you deal with this when you have this situation. I want to know what A is, correct? So I am simply going to put A in here. Do I know what X and Y are at some point in time? And the answer is yes, I know exactly what A or what points are. What I am going to do is take this and plug it into the equation. We've done something like this before. I know what H is, I know what K is. Could this tell me what X and Y is? So if I take Y and put it in as a -5, I don't know what A is, but what's my X? My X would be 4. -2 squared plus 3. Now, do you guys know how to go and solve an equation for one variable? Yes. Do you want to still go back to guess and check? Okay. Guess and check gets rather infuriating, especially when we're doing this. I told you a long time ago. It would be a bad idea. So, I know, that's why I wouldn't do it, I did. So, I got -5 is equal to A multiplied by, what's 4 minus 2? 2, so that's going to be 2 plus 3. Remember your order of operations, gang. -5 is equal to 2A plus 3. You can't go and take the 2 and the 3 and add them together. It doesn't work that way. Subtract 3, subtract 3. So I end up with -8 is equal to 2A. Divide by 2, divide by 2. So that means -4 is equal to A. So, does that turn out to be what you expected it to be? By the way, why did you tell me it was 2? 4 minus 2 is 2. What's 2 squared? You did this one too. I'm sitting here looking at this. That ain't right. Because this has got to be a 4, so it's 4A. Divide both sides by 4, and you end up with -2. So, David, when you sat there and you came up with that half, you were kind of on the right track. If it was going to be narrow, get you down there. but we had to go the opposite way. We flip it around, we end up multiplying by 2. Now, I realize that this isn't what you call the easiest thing in the world to do. But when you are working with this stuff, make sure that you do exactly what is here. Identify your H, identify your K. Then find another point, plug it all into the equation, and solve for A. So, what I'm going to do is I'm going to stop here, and then tomorrow we are going to go over and work some examples.